Okay, welcome to Standard Deviations, Distribution and Z-Scores Part 2. So when we left in Part 1, we ended up with our standard deviation of 6.147. We knew our mean was 22.25. And we knew that these observations, most of them fall in the middle. So now we have this new picture. You can see 68.2% of observations fall between these blue lines, these first lines here. Here and here. 95.4% fall between these yellow lines. So if you trace this up, this red, to the yellow lines and down and across and back up the yellow line, that's 95.4% of observations. So if we took all the people that were average, a little bit above average, and at each point we mapped their speed. So here again is the mean. This is 22.25. So right where this green line is, the peak of the bell right here, that represents the number of people that averaged 22.25 for their speed, or somewhere around it. And then out here to one standard deviation, that's the exact point of where this video is headed. What is that one standard deviation point? So we come back here. Let's start with what we know. 22.25 was the mean of this data set. So let's just write it in. And it's going to round it for us a little bit, and that's fine. So now what is one standard deviation? Remember, this is our ruler. We had to do this thing with the columns to figure out standard deviation. That's because we needed to know what distance will give us these exact percentages underneath this curve, because remember, we have data commonly have this bell shape with more in the middle and fewer observations out on the edges. So we had to find how far out we needed to go to have 34.1% between the mean and the standard deviation. Without knowing calculus, where we would compute areas under a curve, and we could have discussions about that, forget about calculus. Shove it out of the picture and just realize that you can compute standard deviation here this way. Here we get 6.14, and when you do that, it's going to be like magic, statistical magic. It's going to be one standard deviation. So again, we have 6.1. We'll call it 5 because it's going to round it for us anyway. And it did. So we have 6.15, but this is not this blue line. This is not the speed in miles per hour. So to calculate that speed, we need our mean plus that 6.15. So we start at the mean, and that 6.15 is like our ruler. So we started at 22.25, and we line the ruler up against it, and now it extends us out to 28.4. So this blue line corresponds, this one standard deviation corresponds to 28.4. Now what if we want to go out two standard deviations? We go 22.25 plus, we lay down one ruler of 6.15, one standard deviation. We lay down another ruler, a second standard deviation. So we're out up to this green line, we're up to 22.25. We added another 6.15, that's one standard, one unit. We added another 6.15, another standard unit. So that's 34.6. And at this point you can see, okay, only 2.1% plus 1%, and this goes out to infinity, by the way. I've seen an observation out with a z-score of like 150. It doesn't mean they don't happen, it just means they're very, very, very rare. 1 in 100,000 or something. So what we have is basically 2.1. And there's just another 0.1% of cases past this third standard deviation out to infinity. So we have around 97.8% of data up to this point. So if you average 34.6 miles an hour on your bike ride, in this bike race anyway, you are ahead of most people, 97.8% of people. Your speed's faster. So what you can do is, and I've done this before, in fact, I enjoy cycling and running and racing. If I go to a race, I look up the old times, the historical times. I put them in here like this. I find the mean, and I do exactly this, and I get the standard deviation. And then I can say I'll probably be in the top 10% or 14% in this race based on my speed. So that's why this kind of thing can be useful. But let's keep filling this out. So we need to add another standard deviation. Let's just start adding it to this for ease. There's 40.7. Now notice we don't add one here. This goes out for infinity. Okay. You could go 4, 5, 6, but there's not much data out here. So for now, let's just stop at 3. So now we go to this side. This is minus 1 standard deviation. So we're subtracting 1 from the mean. We get that. And now we can subtract another one. And subtract another. So now we have these corresponding numbers filled out. And you should see that in your mind when you see these bell curves, these standard normal distributions. One standard deviation means something. It means that 34.1% of the data are between the mean and one standard deviation. But we know what those numbers are. We can convert them to raw numbers of 22.3 and 28.4. So now you can say something like 68.2% of people, here's the 68.2, just adding up this 34.1 and this 34.1. 68.2% of people finish their bike race between 16.1 mile an hour average and 28.4. So that gives you an idea about how many people are falling within different numbers. And as you can see, 40.7, this is going to be 99.9, faster than 99.9% of people. So almost nobody is going to finish faster than that. Almost nobody finishes slower than 3.8 miles an hour, as long as they were on the bike and they finished. So hopefully this gives you a good introduction to what's going on here. The biggest thing that I would encourage you to do is to realize that this whole thing is 1. And when you're asked to find, you could be asked to find any area based on raw numbers. So you need to be very creative in how you can add things up. So if somebody says find the percentage of cases between -2 standard deviations and 1 standard deviation, you add 13.6 plus 34.1 plus 34.1. But if they say find the percentile for the second standard deviation, if you're 34.6 mile an hour average, how many people are you faster than? You can go adding up all of these numbers, but you can also see that this whole thing adds up to 1. It's 100% of the data. And I have 2.1% here and 0.1% there. So I can just say, okay, this is 2.2% and subtract that from 100. That also gives me this whole area up to this yellow line. So be creative with that. Be sure once you get this Math is Fun app here to just play around with it a little bit. And you can select here up to Z, Z onwards, or 0 to Z. This is the mean to Z. So it'll let you look at the Z-scores down here at the bottom and what areas those correspond with, and get a feel for how to find different areas. And sometimes we'll use a tool like this in helping us solve the problems that we'll be doing. From now on, you'll refer to these kind of Z-score tables or charts or tools to help us find this area under the curve a lot of the time. I also encourage you to start memorizing these percentages. What is the percentage between the mean and 1, between 1 and 2, between 2 and 3, because they're never going away as long as you do statistics. And if you memorize them, they make your life very, very happy. One final